Hi science friends, today we are going to be reviewing electrical circuits. I know this was new, parts of it were new to a lot of people, so we're going to take some time to review it. So the first thing that I ask you to do is make a series with one light bulb. So remember, a series circuit has one path for those electrons or energy to flow. It comes out the negative side of the battery and goes through whatever we're trying to make work here, a bell, a buzzer, a fan, a motor, light bulb in our instance, and it returns back to the positive side of the battery. So I've already got it connected on one side. We're just going to connect the other side and see, make sure that our light bulb, which indeed lights up. Okay, so you've got your power source, which is your battery, your wires to connect it, and then we've got our light bulb in the middle. The second thing that I ask you to draw is a series circuit with two bulbs. So now we're just going to add that second bulb in here. So I'm going to detach it here, add our second bulb. Okay, we also need something, see right now we don't have a complete path of energy. So we need these two connected in order to have a complete path of energy. All right, as you notice, those light bulbs do light up, but my goodness, quite a bit dimmer than they were previously. Okay, that's because they share electricity. Certain amount of energy comes out this negative side. It only has one path, one direction for it to go. So whatever this doesn't use, the other bulb gets the leftovers. So it's sharing energy, which makes it not as bright. The next thing, the third thing that I ask you to do is a parallel with two bulbs. So in order to make this parallel, I'm going to disconnect a few things here. Remember, a parallel circuit is going to need two paths of energy, right? It has two or more paths of energy. So we are going to create that right now. Two or more ways for that energy to travel. Oh, that's in there all the way. Hang on. There we go. Okay, so now we have created two different ways for energy to go. Energy can come out the negative side, travel through this light bulb, come back up to the positive side. That's one direction it can travel. It can also travel to this terminal. It can keep going past that and come to this second bulb, travel through and back up to the positive side. So it now has two paths of energy. So that was a parallel with two bulbs. So now I asked you to add a switch that's only going to turn off one bulb. Well, if we're only going to turn off one bulb, we've got to interrupt the path either to that one light bulb or back to the positive side for that one light bulb. All right, I'm going to pause it for a minute while I get this all connected, and then I will show you in a minute. Okay, we've got everything connected now. We still have two paths for energy to flow. We still are coming out. It can come back up this way, back up to the battery, or it can go to this terminal and come on through this one. What we've added is this switch. And when what I asked you to do is add a switch that turns off only one bulb. So we've got to interrupt the flow of energy for just one bulb. So what happens now if I open this one, the switch is now open. The metal is no longer touching, so the switch is open. So now the energy just has one path to flow. It's flowing here, but it doesn't have a way to get back to the positive side. Remember, it has to go from the negative all the way back to the positive. Since I've interrupted it because I've opened up that switch, electrons stop right here, and they can no longer get back up. So that only allows one bulb to turn on. Your next question, I ask you to draw an open circuit. This definitely would represent an open circuit. And then I also asked you to do a closed circuit, which simply goes like that. So you can draw it with just a series circuit, or you can draw it in the parallel like I have here. All right, we are going to try some predictions. First, I'm going to pause it for a minute. I want you to make some predictions about these objects that we have listed: a penny, a rubber ball, pencil, aluminum foil, styrofoam cup, Play-Doh, cotton ball, yarn. I want you to make some predictions as what you think is possibly going to happen when I put these in the circuit. All right, hopefully you took a moment and made a prediction as to what you think is going to happen with these items. So first thing we're going to try is the penny. So I have just gone back to our series circuit, so we have one simple way to figure out if it's working or not. We're not going to be worried about connections or anything like that possibly not working. So if we grab our two metal wires and we connect the two, we can see that our circuit is still complete as the light bulb lights up. So now what we're going to do is we're going to place our electrical sensors on either side, both on the penny, and see if it lights up. Okay, they're not touching. Wish you could see that a little bit better. I don't have them physically touching. They're both just touching the edges of the penny. And as you can see, the light bulb lights up. All right, next item we have on here is a rubber ball. And again, we're just going to touch either side. I'm going to try it flat as well. As you can see, the light bulb does not light up. Next item we're going to try is the pencil. And if we hold it on either side, our light bulb does not light up. Next thing, we don't have any aluminum foil, so we're going to have to skip that one for today. We're going to try the styrofoam cup. No results with the battery, or with the light bulb, I mean. The next thing we're going to try is our Play-Doh. And what happens there? It actually lights up. I bet some of you are thinking, why does that work, Miss Vinson? Good question. All right, how about the cotton ball? No results. For some reason, STAAR always likes to throw in a piece of yarn and see if that piece of yarn works. As we can see, if we hold it end to end, it does not light up the light bulb. Tell me what you think about the Play-Doh. Record your thoughts. Go ahead and turn that in. Make it a great science day.